What is a portion of a whole? So there's a good visual for this. Here I have a box. Well, I have 6 boxes and 4 of them are shaded in. So this is actually 4 boxes out of 6 boxes, meaning this is actually the fraction 4/6. Now, let's say I want to take 1/2 of whatever we have here. Well, we can redraw this box. And this time we're going to take every single box that we had and cut each of them into half. Like this. I'm going to cut those 2 in half, cut these 2 in half, and cut the last 2 in half. And now we're only going to take, so for instance, I did this, this, and then that. Now what I'm going to do is I'm only going to take half of each one of these boxes I had. So this is the first half. Here's the second half. Here's the third. And the fourth. Now, this new fraction is 4 boxes shaded out of a total of 12 boxes. So now we have 4/12. I can rearrange this to have all the boxes in one kind of area. And these 4 on top will be where I rearrange them to. So all I'm doing here is I'm just shifting these 2 up 1 block. And now, right, these are still all cut out in half. Now I can recut this up, this box, into a new one. And I can cut it up like this. I haven't changed anything here. I've just recut up the box. And this is now 1/3. So what we did is we took 1/2 of 4/6, and mathematically this is 1 times 4 over 2 times 6, which gives us 4/12. And we can reduce top and bottom by not 3 but 4. And that gives us 1/3. So that's what I did mathematically with this visual here. So there's this nice visual that can go along with the multiplication of fractions. However, the algorithm is quite simple. We multiply the numerators and we multiply the denominators. So let's look at another one here. 4/5 times 1/6. So we're taking a 6 of 4/5, or we're taking 4/5 of 1/6, whichever way you want to look at that. But the algorithm that we use is multiply the tops, 4 times 1, and multiply the bottom. 4 times 1 is 4, 5 times 6 is 30. We can divide top and bottom by 2, giving us 2/15. And that is completely reduced. Let's look at one more. Same algorithm here. 8/9 times 3. Now, because here we have a whole number, we're the first one to make it into a fraction. We can do that by dividing it by 1, because 3/1 is 3. We're not changing anything with that number. We're just making it stated as a fraction. Now we can use the algorithm. 8 times 3 over 9 times 1, which is 24/9, and that cannot be reduced. Oh no, it can. It can by 3. 24 divided by 3 is 8, and 9 divided by 3 is 3. Now, what we can do here is whenever we take a multiplication of fractions, we can do this thing called cross-canceling. So this step here is the reducing step, reducing kind of phase. We do this as many times as necessary. What we can do, however, is when we multiply the fractions, we can reduce as we go. So we could say 3 divided by 3 is 1, and 9 divided by 3 is 3. You can always reduce numbers that are on the top and bottom in pairs. You cannot reduce numbers that are on the top, just on the top, and you cannot reduce numbers that are just on the bottom. You have to have one on the bottom and one on the top, no matter where they're at. They could be, they could both be in the first fraction, the second fraction, or cross the fractions. Now, if we follow this, 8 times 1 over 3 times 1, and you see we get 8/3, which is the same thing we got previously, but it kind of makes it faster. I think it makes it faster in general. For this top one here, we could have divided 6 by 2 and gotten 3, and divided 4 by 2 to get 2. That's how cross-canceling works. This, of course, is the exact same thing as this step here. So if you're getting confused by that, just divide in the end. That'll work out just fine. Let's consider multiplying two mixed numbers instead. So let's have 2 1/6 times 1 1/2. Now there is a way of multiplying mixed numbers by leaving them the way they are and doing the multiplication. It's going to be too complex. It's going to take too much work. I think it's much easier to first change this into an improper fraction and then change it back if we need a mixed number in the end. Okay, so we're going to do 6 times 2 and then plus on the top, 2 times the 1, and take whatever that is and add to the top. So 6 times 2 is 12, plus 1 is 13 over 6 times, so that was the first one. We'll do the second one now. 2 times 1 is 2, and then 2 plus 1 is 3 over 2. Make sure you keep the same denominators for these fractions. Only the numerators are being changed here. Okay. Let me get rid of these circles just so I can read it easier. Now, we can do this one of two ways. We can multiply straight across. 13 times 3 over 6 times 2. That gives us 39 over 12. And of course, we can divide by 3, giving us 13 over 4. And that's reduced. We can also cross-cancel. We can take a 3 out of the top here and a 3 out of the bottom, giving us 13 times 1 over 2 times 2, which is the exact same answer, which is what you'd expect to have. Like I said, I think the cross-canceling, that typically is faster. The numbers are smaller to work with in the end multiplication. So that typically makes it easier. Smaller numbers are easier to work with. All right, we got a few more here. 4 over 7 times 28 over 2. Let's cross cancel. This one's there's a lot of cross canceling we can do. 4 divided by 2 is 2, and 2 divided by 2 is 1. 7 divided by 7 is 1, and 28 divided by 7 is 4. Now we have 2 times 4 on top, and 1 times 1 on bottom. This is 8 over 1, and 8 divided by 1, that's just 8. So that would be your answer there, not 8 over 1, just 8. Okay, 6 times 1 1/3. We're going to make both of these into fractions. So 6 over 1 is the first one. And then 3 times 1 is 4. Sorry, 3 times 1 is 3. And 3 plus 1 is 4. So we have 4 over 3. Let's just do the multiplication now, and then we can reduce in the end. You can cross cancel here. Do that if that makes sense. 6 times 4 on top, 1 times 3 on bottom. 6 times 4 is 24. 1 times 3 is 3. And of course, we can divide top and bottom by 3, giving us 8 over 1. Hey, which is 8 again. Imagine that. All right. Now we're going to do 2/3 times 3/2 times 2. So just take this in steps. Do the first multiplication, right? PEMDAS says we need to work left to right. And we do the first multiplication we see left to right. So let's look at this one first. 2 over 3 times 3 over 2. Here you can see we can cross cancel. 3 and 3, we can just divide by 3 there. And then divide by 2 there, giving us 1 over 1, which of course is just 1. And now we see that this is going to be 1 times 2. We don't even have to do fraction multiplication because this is just 2. Okay. That's the multiplication kind of algorithm here. Multiply the tops, multiply the bottoms, reduce, cross cancel if you can. That makes things simpler. Now let's look at some application problems. Find the total length of 12 pieces of wire, each 9 3/16 inch long. So if we have 12 pieces, each 9 3/16 inch long, to find the total length, we just multiply 12 times 9 3/16. So we have a whole number and we have a mixed number. We need to change both of these into fractions. 12 is the same thing as 12 over 1. And then 9 3/16. Let's change that to an improper fraction. 16 times 9. If you're unsure, just grab your calculator. Of course, do 16 times 10, which is 160, and then minus 16 from that. But 144. 144 plus 3 is 147. We keep the same denominator. Now, in this type of problem, you can multiply going straight across the top and multiply in the bottom and then reduce. Using a calculator will help you out with that. These numbers are quite large, so it gets to be, a lot of stuff to work with. So I'm going to first reduce. 16 divided by 4 is 4, and 12 divided by 4 is 3. Now we get 3 times 147 over 4 times 1. 3 times 147, that's 441 over, of course, 4. And since we're trying to find the total length of all this, we're trying to translate this back into like kind of a real world scenario. 441 over 4 inches long. That doesn't really make any sense naturally. So we're going to convert this back to a mixed number for the application. So how many times can 4 go into 441? Well, you can just take a calculator. Go 441 over 4. Doing this on a calculator gives you 110.25, which means the big number is 110. Then you could take 110 times 4, gives you 440, and 441 minus 440 gives us just 1. So 1/4 is remaining, and this is in inches. All I've done here is I've used the calculator to help with the big work, which is how many times can 4 go into 441. 4 can go in there 110 times evenly. And how many times is that? Well, 4 times 110 is 440. That's why we have to take 440 away from 441 to get to one and 1/4 remaining as the part of the fractional part of the mixed number. What is the volume of a rectangular box? Oh, that should be box. Let me just I like that. With the interior dimensions of 12.5 inch long, 1/8 inch wide, and 4 1/4 inch deep. Volume is, of course, length times width times height. So all we have to do is multiply these numbers together and see what we get. 12.5 inch long, 8.5 inch wide, 4 1/4 inch deep. These are all mixed numbers, so the first thing we should do is change them into improper fractions. 2 times 12 is 24, plus 1 is 25. 8 times 8 is 64, plus 1 is 65. 4 times 4 is 16, plus 1 is 17. Okay. Now, in this case, there isn't any cross-canceling we can do. All the numbers on the bottom are just powers of 2. They're just 2 times 2 times 2, or 2 times 2, or just 2. And all numbers on top are not even, which means they can't be divided by 2. So, in this case, we have to multiply it all out and then reduce from there. So, I'm going to start off with, to kind of keep it clear what I'm doing here. I'm going to start off with the first two. 25 times 65 over 2 times 8. This is, of course, multiplying 17 times 4. Using a calculator, 25 times 65 is 16. 25 over 16. And now we can do 1625 times 17 over 16 times 4. So on top we have 27625 over 64 on the bottom. So to do this, to figure out what is the because this is an application problem and we were given mixed numbers to start with, I'm going to end up with mixed numbers in the end. Okay, that's my idea here. What I want to do is I want to figure out how many times can 64 go into 27,625. I don't know it off the top of my head. It would take too long to calculate, so I'm going to use the calculator. So I'm going to use 27,625 divided by 24, and that gives me 431.640625. Okay, I can ignore the decimal. That doesn't really matter in this case. What we do know is that 64 goes in 431 times evenly, and then of course a little bit more. That's the 64, 065. So we have 431. That's the big number. Now we need to figure out how much is that. How many times, what's the number when 64 goes in 431 times? So we go 64 times 431. 64 times 431 equals 27584. And we take that number away from the number we started with on top. 27625 minus 27584. 5 minus, and that gives us 41, which means 27,625 over 64 is 431 and 41/64 inches, and this is in volume, so it's going to be inches cubed. And that is the volume of the box with those dimensions. Here's a metal bar with consecutive holes that are 5/16 of an inch spaced out. So from the center, from this hole to the center of this hole is 5/16 of an inch. What is the total distance between the first and the very last hole for this situation? So here's the first one, right? We're going all the way to this one here. So we're trying to figure out what is this distance here. So what is that distance there? So the real question is how many of these 5/16 spaces do I have here? Well, here's the first one. Let me draw it in red. There's one. Then we have this one, which is 2. And we have this one, which is 3. And you see we have one here, another one here, there, that one, and this is the last one. So there's actually 8 of them. There's 8 spaces here. So if we have 8 times of the 5/16 of an inch space, all we have to do is 8 times 5/16 of an inch. Of course, 8 is over 1, and you can see here we can cross cancel. 8 divided by 1 is 8, and 16 divided by 8. Sorry, 8 divided by 8 is 1, and 16 divided by 8 is 2. And we get 1 times 5, or 1 times 2, which is 5/2 inches. Of course, you don't read it that way. We reread it as a mixed number. Let's change it to that. How many times can 2 go into 5? They can go in there 2 times. 2 times 2 is 4. 5 minus 4 is 1. And we have the denominator of 2 still remaining. Whenever you make it a mixed number, make sure you keep the same denominator. The numerator will change, and the mixed number will have a whole number out in front. That's where the 2 is. But 2 1/2 inch is the answer to this problem.